Hello there. This is the third episode of the C++ learning series. In this episode, we will explore numbers in programming. Now, why do we need numbers? Computers already work with just a bunch of ones and zeros, so the main thing that lets a computer run is numbers. It's literally called a computer because it computes numbers. Now, if we go to math, we see that we have some number sets. The biggest one is the real numbers. Inside of it, there are rational and irrational numbers. Irrational numbers are numbers that have infinite and random patterns after the decimal point, like pi, for example. If we humans can't write them fully, then computers can't either. So it's impossible to have irrational numbers on computers. We remove these. Now for rational numbers. Rationals can be finite or infinite, but have a static pattern after the decimal point. The finite ones can be stored, but the infinite ones cannot. Why? Because on paper we can write these numbers as fractions, but on computers there's no such thing. Inside rational numbers there are whole numbers. These are the easiest ones. So our computers can work with finite integers. Integers here can be negative or positive whole numbers. And then we have floating point numbers. These can be negative or positive decimals. What about infinite decimals? They are written approximately, not the full value, but an approximate value of it, like up to 10 digits or so. Anyway, we've understood that we have integers and floating point numbers. So now, how do we use them in C? And by the way, I will never mention C++ numbers because they're the same as in C. To start, open your main.c file, and inside main, write int, then the name you want. Let's call it myvar. Then put the equal sign and any number, I'll go with 700, and at the end, put a semicolon. This is called a variable. A variable is where we store our values, and because this value might change, we call them variables. As the first keyword, we write the variable type. Here we defined an integer, so we wrote int. Then after the type, we write the name of the variable, and then we put the equal sign to assign a value to our variable. Now, if we use decimals with int, it will round down to an integer. It won't store it as a decimal. So if we write 7.3, the actual value stored will be 7 only. So now what? How do we store decimals? We can store decimals using floating point numbers or simply float. And now the actual value inside my var is 7.3. Now you might ask, where is this number stored and how is it stored? These variables are stored in your memory, in other words, random access memory, RAM. And because the computer works with binary, ones and zeros, the RAM stores your numbers as binary too. And if you're curious about binary, in the next episode, I'll talk about it. Each one or zero is called a bit. And if you put 8 bits together, that's called a byte. The smallest unit a computer can handle is a byte, or 8 bits. If you have more bits, you can store bigger numbers. If you have n bits, this is the formula to find the largest number that can be stored. This formula works if we ignore negative numbers, but if we consider negatives, the biggest number is computed using another formula. So in C, we have more types than just int, similar types but smaller or bigger in size. These types are char, a 1-byte integer, short, a 2-byte integer, int, a 4-byte integer, long, an 8-byte integer. These sizes are true if you compile your code on a 64-bit compiler. But what is a 32-bit or 64-bit program? In earlier times, CPUs weren't powerful enough, so they handled 8 bits at a time. That's why they were called 8-bit CPUs. Then they evolved to 16-bit, then 32-bit, and finally 64-bit CPUs. If you have a program written for 32-bit CPUs, that means the program knows that the CPU is limited to 32 bits and doesn't try to work with larger numbers. So in C, they wanted to make the long type work for both 32-bit and 64-bit programs. So they made it so that in 32-bit mode, int is 2 bytes and long is 4 bytes. But in 64-bit programs, int is 4 bytes and long is 8 bytes. Integers can be represented in 4 types, as we mentioned. But what about floats? Floats can be float or double. The float in 32-bit programs is 2 bytes, and in 64-bit programs, 4 bytes, while double is 4 bytes on 32-bit and 8 bytes on 64-bit programs. Now, what is a local and what is a global variable? When we declare any variable inside a function, like the variable inside the main function, it's called a local variable, and it's accessible only inside main. But if we declare it outside, it's a global variable, and it's accessible anywhere in our code. We'll understand this clearly when we get to the functions episode, but that's for the future. The auto keyword can have two meanings. If you write auto in front of the type of the variable, it tells the program that this is a local variable. In modern C++, this is useless because it's already a local variable by default. But in C++, auto has another meaning. If you write auto as the variable type, not in front of it, the type will be determined automatically. So here, myvar1 is an integer and myvar2 is a floating point number. I didn't specify anything. It just knows automatically. And don't forget, this only works in C++. This episode was about variables. The next episode will be about understanding binary numbers, so it's not a coding episode. See you next time.